We've seen a lot of recent news stories discussing how the SARS-CoV-2 virus spreads, and whether that primary spread is through respiratory droplets or something called airborne transmission. We'll explore what those terms mean in this episode of Shareable Science Beyond the Blog. Welcome to Shareable Science. Science you can share. So, this episode is going to dig into the weeds a little bit, and I apologize up front, but I think it's worth having that level of scientific discussion. So since we first started making these videos back in March, in the early days of SARS-CoV-2, we have talked about two primary ways that the virus actually is transmitted. The first is by touching infected surfaces, and you might remember back to March and April, we were exploring whether we needed to be wiping down our groceries or wiping down our mail or leaving things outside. The idea being, if you touched a surface that had virus on it that might have been touched by someone else or coughed or sneezed on by someone else, and you brought that to your face, you could transmit, you could pick up the virus. That is still a possibility, but it seems less likely that this is what we need to be concerned about. We should still be keeping surfaces clean and paying attention to what we're touching, but this does not seem to be a primary driver. On the flip side, we also talked about respiratory droplets. This is where I had that infamous discussion about staying outside the snot spray zone. Those larger droplets that come out of our mouth or nose that carry the virus, that travel a short distance, maybe, 4, 5, 6 feet at most before gravity pulls them to the ground. So you can see another one of my stellar artwork drawings. You can see if we have an individual who's infected and the different size droplets are the red, orange, and yellow from largest to smallest, that these large droplets fall to the ground pretty quickly, even the medium-sized droplets. But if you're within that window and you are hit from those projections, those ballistic projections of respiratory droplets, you could get infected. That's the primary way that we've talked about infection. But even back in early spring, there were questions about another type of transmission, and that was airborne transmission. So these are much smaller droplets. You can see them here as the yellow dots that, because they are smaller, can carry through the air for longer windows of time. So this field of understanding transmission involves a whole set of different scientific and clinical teams: infectious disease experts, virologists, epidemiologists, and aerosol scientists. Each of them has an area of expertise, and each of them have brought their voice to the table. The challenge is right now there isn't consensus. There seems to be two different groups of thought on whether aerosol transmission is a viable way to spread SARS-CoV-2 or is not. So, like almost everything else we've talked about in this series, it's complicated. Let's talk a little bit about what we do know about respiratory droplets. So a 2011 study looking at the size of the particles that come out of our mouth and nose when we speak and talk and exhale and cough and sing found that there's a whole range of size of those particles. Now, this graph is actually measured on a logarithmic scale, so we are moving up by a power of 10, by a factor of 10, every time we move down the board. And these are measured in microns. Microns are tiny, tiny units of length. It's 1/1,000,000th of a meter, or about 1/25,000th of an inch. So just for a frame of reference, the average thickness of a human hair is about 70 microns. So we're talking about things that are much smaller than the thickness of a human hair, or a little bit larger. So with that background, viruses are really small. They're usually down here at less than 1 micron in size. The size of the respiratory particles that you and I give out runs anywhere from less than 1 all the way up to 1,000 microns, with two kind of clusters, one concentrated right around, half to 2 or 3 microns, and one that's more like 50 to 300 microns. So smaller size and larger size. The differentiation here between an aerosol and a droplet is still up for discussion. Some folks say that anything larger than 5 is a droplet and anything smaller is an aerosol. Other groups say that the line moves a little bit more. That's beyond what we need to pay attention to. But the point I want to make is that you and I, in our everyday conversations, in our everyday speaking and singing and coughing and sneezing, are giving off a whole range of particles. And the key question is whether there's virus in the smallest of those particles, and if it's enough virus that if it floats through the air and I inhale it in from 7, 8, 10 feet away, will there be enough virus in those particles to cause me to then become infected? That's really the crux of this argument. Do I need to be concerned about inhaling virus if I am outside that 6-foot physical distance? So, to give you an example of what I'm talking about, we're going to do a little bit of science. This is always a little dangerous because you're never quite sure if this is going to work the way you hope it does. But I've got 2 different bottles here. I've got a spray bottle full of ethanol, and then I've got a bottle I bought from the grocery store of an air freshener that produces a fine mist. And the idea is that the spray bottle produces larger droplets, and the aerosol produces finer droplets. So let's see if this works. All right, I can work with this. So, larger droplets, these are those respiratory droplets that would be within that narrow window. The finer mist are the aerosols that travel further in the air. And even though my cameraman Chris is more than 6 feet away from me, I bet that in a few seconds he's going to smell hint of fall because the aerosols travel through the air. They're not pulled down by gravity. So that's an example of what we're talking about when we talk about, is it transmitted in larger droplets or in smaller aerosols? Here's why this matters. Because it impacts the way we think about how we potentially reduce the likelihood of transmission from one individual to another. We need to think about physical distancing. If we are concerned about aerosol transmission, then yes, being outside of the snot spray zone is important, but you also have to think about, could I be inhaling aerosols from someone who's infected who might even be on the other side of the room? We also have to think about masks in a different way, because now I am asking, is my mask not only helping hold in my own respiratory droplets, but also potentially my own aerosols? And is my mask actually giving me protection against someone else's respiratory droplets and aerosols? So that's when you're talking about how many layers of fabric are in my face covering, and what's the type of fabric that it's made from. And importantly, how well does my mask fit? Because if I have on a loose-fitting mask and someone sprays air freshener, for example, in the room, and I can smell it, it is getting in around the open, sagging gaps in my mask. And then importantly, it raises an issue about ventilation indoors and how do we ensure that there is enough ventilation, that we're bringing in enough outside air, or that we're filtering the air appropriately. So this is why we want to be able to solve this question of, is it primarily transmitted through respiratory droplets? Is some of it through aerosol? How much of it is potentially through aerosol if it is? Lots more data to come. So it'll be a while before we settle this once and for all. But I think a consensus is beginning to emerge that there is at least some transmission through aerosols. It's just how much through aerosols is a question that we're trying to solve. All right, I know that was in the weeds. If you find this useful and you think other people might find it useful as well, please share this. Thank you for watching. I look forward to seeing you on the next episode of Shareable Science Beyond the Blog. Take care.